Greetings, my beloved scholars. I'm Mr. Okafor, PC, your online physics teacher. Our topic of discussion today is the concept of momentum. The concept of momentum. Anywhere there are particles of masses moving, anywhere bodies are in motion, therein is momentum. Anywhere a body is in motion, there is momentum. Momentum is highly concerned with the speed and mass of a body. Any body moving has momentum. Okay, today we'll be emphasizing on two key examples. We'll be taking one example from the world of sports and the other example from the world of military or warfare. Okay, let's start with military. The difference between bullets is momentum. Any bullet that has a greater mass and also moves at a greater speed compared to another bullet that has a smaller mass and a smaller speed do not share the same momentum. The bullet with a bigger mass and a greater speed has a higher momentum. So what we target in military is to gather more momentum, to increase momentum of our missiles. Any weapon of warfare that has a greater mass and also has a greater speed has a greater momentum and has a greater tendency of destruction. We must have heard of ballistic missiles. Yeah. Ballistic missiles are missiles that are projected into the space. They come in a greater mass, and because they come in a greater mass, we need a greater force to make them move at a greater speed, and they cause a massive destruction. Momentum is concerned with mass and the speed of a body. Any body that has a greater mass and a greater speed has a greater momentum. So bullets with greater masses and greater speed cause more harm compared to bullets with smaller mass and smaller speed. The higher the mass and the higher the speed, the greater the momentum. This is what we target in warfare. Anytime we make missiles of greater mass, we tend to also give them another advantage, which is what? Speed, and the momentum is highly increased. Okay, then let's come back to sports. In sports, we have categories. These categories is due to momentum. Take football, for example, we have feeder team and senior team. In senior team, you see players of within the same age brackets because it's believed that they will have similar or the same, although most times not the same, but similar body masses. Similar body masses. So that when the players move, they gain speed and vary their momentum. So they will have a kind of similar momentum. When players by accident collide, there won't be much damage or injury sustained. There won't be much damage or injury sustained due to similar momentum. So a player with a bigger mass and a greater speed has a greater momentum, while a player with a smaller mass and a smaller speed has smaller momentum. Momentum is highly attached to mass and speed. Okay, let's see from the board. Momentum is denoted with symbol elongated P. Momentum is proportional. Momentum is proportional to speed. Momentum is proportional to speed. That means the greater the speed, the greater the momentum. And this is direct proportion. The smaller the speed, the smaller the momentum. Okay, let's go back to the variation on the board. Making this a proper equation, momentum is equal to this direct proportion, introduce a constant, then speed. Our constant of proportionality here is mass. Mass. Provided the mass of a body is fixed, provided a single player is considered, when the player increases his speed, his momentum increases. If we take emphasis on a single player, the mass is fixed. Provided the player is not eating or putting away anything from the body. When the player increases his speed, the momentum is increased. So most times you hear in sports, gather momentum. Gather momentum. It simply means increase your speed. Increase your speed. Okay, then let's go back and complete our equation. Momentum now is equal to mass in place of the constant and what? Velocity. Momentum is mass times velocity. Okay. Momentum also has to deal with balance in some situations, like in athletics. In athletics, although we want our athletes to gather momentum, but there should be a kind of temperance. There must be a balance because what we judge in races is the speed and not just momentum. an athlete with a greater momentum compared to the one with a smaller momentum, it may not be the case that the athlete with a greater momentum will always win the race. No. In races, we judge the speed and not the momentum. Take it again. In races, we judge the speed and not the momentum. That explains why an athlete with a smaller momentum may win the race against the one with a greater momentum, because what we judge in race is the speed and not just the momentum. This is why athletes, they work on nutrition. They don't eat anyhow. They try their best to balance their body mass. They don't want to take their body mass above what they can carry, because mass can also affect speed. When your speed is not increasing and your mass is increasing, that mass is also a barrier against your speed. The mass can also affect your speed. Okay, let's see it from the board, what I'm trying to convey. Okay, here we have two athletes. Athlete 1, athlete 2. Athlete 1 has mass of 100 kg, speed of 5 meters per second. Then athlete 1 will have momentum of 100 times 5, 500. Then let's get the units. Unit of mass is kg. Unit of speed is meter per second. Therefore, momentum becomes kilogram meter per second. This momentum of the first athlete. The first athlete. Then coming to athlete 2. Athlete 2 has a smaller mass, 5 kg. Then a greater speed compared to the first athlete, 10 meters per second. Then let's see the momentum of the athlete 2. We'll be having 5 times 10, 50 kilogram meter per second. Momentum of athlete 2. From the board, you can see that the first athlete has a greater momentum and the second has a smaller momentum. But the question is, who won the race? Athlete 2, because he has a greater speed, 10 meters per second, while athlete 1 has smaller speed of 5 meters per second. You can see athlete 2 is the winner in the race. But when it comes to momentum, athlete 1 is bigger. So in race, we judge speed and not just the momentum. But the advantage with momentum is that if athlete 1 should collide with athlete 2, athlete 1 will kill athlete 2, because athlete 1 has a greater momentum. So when it comes to collision, athlete 2 is in danger. Thank God it's not martial art. That's why in martial art we also have categories. We have martial art for kids and for adults because they do not possess the same momentum. But in race, we are concerned with speed. This is why athletes that partake in races, they feed on fruits and vegetables to vary their body mass, to keep it in a moderate value. Momentum. The idea of momentum is the idea of mass and velocity. So in warfare, we target high momentum. In sports, we also target high momentum. But we're highly concerned with speed. So if the mass of the body is fixed, as the momentum is increasing, the speed is increasing. As momentum is reducing, the speed is doing what? Reducing. Therefore, momentum is equal to mass times velocity. We have two major kinds of momentum. What we call linear momentum and angular momentum. You can see from the board. Linear momentum, angular momentum. When a body moves on a straight line, linear. When a body moves on a straight line, it's called linear momentum. The mass of that body times its speed on that straight line is linear momentum. But when a body moves in a curve, when a car goes about a roundabout, when the earth spins about its axis and spins about the orbit of the sun, it's called angular momentum. So the idea is not too far. The difference is a straight line and a curve. So from our linear momentum, we can deduce formula for angular momentum. Just a very slight deduction. Okay, let's see. This is linear momentum, mass, linear speed. The symbol capital L is used for angular momentum. Capital L for angular momentum will maintain mass. Mass of a body does not know the difference between linear and angular. The mass is fixed. Remember, it's a constant. So the speed now begins to go in a curve. And when speed goes about a curve, it's no more called linear speed. It's now called angular speed. So use the symbol W for angular speed. Angular speed. And angular speed has its own formula. Angular speed can be deduced as W is equal to 2 pi f. Our angular speed is 2 pi f. 2 pi f. 2 pi is a constant. F is frequency. Frequency. Therefore, we can substitute in the form of finding angular momentum. our angular momentum can also be L is equal to M, which is fixed. Then we'll now sub 2 pi F in place of W. So we'll be having 2 pi F. Angular momentum is equal to mass times 2 pi F. This is also form for finding angular momentum. So the units, we also pick the unit from the formula. The unit of mass, kilogram. The unit of angular velocity, the same way we say meter per second. In the angular world, we don't measure distance in meters, we measure distance in radians. In the angular world, distance is measured in radians. Radians. Contracted as rad. So the way we say meter per second, we now say radians per second. Second time is the same in linear and angular world. So our angular speed becomes rad per second. Therefore, angular momentum will be kilogram rad per second. Kilogram rad per second. That's the SI unit of angular momentum. Angular momentum. Okay. Momentum is also highly rooted in Newton's second law of motion. Recall, anywhere there is motion, there is momentum. So Newton gave us 3 laws of motion. With time, we learn these 3 laws. I will just make emphasis on the second law. Newton cannot talk about motion without making reference to momentum. Otherwise, it will be incomplete. So Newton's second law of motion is the law of momentum. Let's see from the board. Newton says in his second law that the rate of change in momentum is directly proportional to the applied force and moves in the same direction with the applied force. I'll go again. The rate of change in momentum is directly proportional to the applied force and moves in the same direction with the applied force. This statement is very simple statement. By the time we go on explaining what it means to understand better, let's see the equation before we do the proper explanation. Newton is saying rate of change. Anytime we say rate of change, there is time involved. Time is the denominator. Newton said the rate of change in momentum. When we say change in momentum, we mean there are two momenta. Final momentum and initial momentum. The final one is mv and the initial one is mu. Mass times final velocity minus mass times initial velocity. The word change means minus. The change between 4 and 1 is equal to 3. 4 minus 1 equal to 3. The rate of change in momentum, rate is ratio involving time as a denominator, is proportional. The rate of change in momentum is directly proportional to applied force, equal to force, and moves in the same direction with the applied force. See what Newton is saying here. Newton is saying that if you want anything to increase its speed, you must give a body, you must give that body that you want it to increase its speed, you must give it a force that is greater than the force keeping it at rest. Paying attention. If a body is at rest, a force is keeping it at rest. So if I want that body to increase its speed with time, if I want it to increase its speed or increase its momentum, I must give that body a force greater than the force keeping it at rest. This is what Newton is saying. This formula goes back to F is equal to ma. But today we are concerned with the momentum aspect of this formula. Okay, I will show you the two. Okay, let's go to momentum aspects. Let's make this linear equation. We have over 1 cross and multiply. F times T, Ft, equal to anything times 1 is that thing. Mv minus mu. That means force times time is equal to final momentum minus initial momentum. This Ft is called impulse. In physical science, force times time is impulse. It simply means impulse is any activity that happens within a very tiny time, within a very short time that cannot be measured. Milliseconds, nanoseconds, 1 second. Impulse, very difficult to measure. When football hits on the wall, it will be difficult to measure the time it takes the football to hit the wall. Before you push the stopwatch, the football must have gone back from the wall, must have bounced back from the wall. That type of activity or phenomenon is what we call impulse. a greater force and a shorter time is impulse. So 1 Newton is trying to tell us that impulse is the same as change in momentum. You can see it on the board. Another name for impulse is change in momentum. Take note. Impulse equals change in momentum. So take note of this formula. Take note of the formula. Impulse is equal to change in momentum. Therefore, the unit of momentum can also be the unit of impulse. We use the symbol capital I for impulse. Change in momentum. Impulse is equal to change in momentum. Then notice, impulse, force is Newton, time is what? Seconds. This is why most times in physics textbooks, the unit of momentum is Newton seconds, because Newton seconds is the unit of impulse, and impulse is the same thing as change in momentum. Then what if the body was initially at rest? When the body is initially at rest, we say that its initial momentum is 0. If the initial speed is 0 meters per second, therefore, no matter the mass times 0, it will also be what? 0. Therefore, impulse can also be the same thing as what? Just momentum. Impulse is equal to momentum. When the body is initially at rest, we now have impulse is equal to mv, which also explains the unit to be Newton seconds. Newton seconds. Dear scholars, today you must have come to agree with me that momentum is highly connected with mass and speed. Taking the mass or taking a particular player as our consideration, when the player increases his speed or her speed, the momentum is increased. So momentum is proportional, directly proportional to speed. And momentum can also be called impulse. Change in momentum can also be called impulse, from Newton's second law of motion, which states that the rate of change in momentum is proportional to the applied force. There are 3 key equations to note in momentum. 3 key equations for you to excel in your external exam. And they are: the first is this. 3 key equations for momentum. What do we call M1 U1 plus M2 U2 equals M1 plus M2 V. This is the first one. Okay, let's start with that one. The equation on the board explains momentum. It explains momentum. There, 2 bodies will collide. 2 bodies will collide. Take for instance, we have human body. We have human at rest, not moving. The speed is 0 meters per second. The mass is 2 kg, for instance. Then we have bullets coming, streamlined. Then the speed of the bullets, initial speed, that's why I'm using U. Initial speed of the bullet is 100 meters per second or meters per second. And the mass of the bullet is 1 kg. Let's explain the equation describing collision of bodies or collision of momenta as seen on the board. So this is the M1 and U1. This is M2 and U2. So when the bullet enters the human body, there is collision. They've joined. That's why we have flux. The momentum here joins the momentum there. Then equal to, let's see what will happen. This is what will happen. Then both will now join. Both masses will add up. That's what we are seeing here. Both masses will add up and they will now fall at a common velocity. They will fall down at a common velocity. Like you can see, they have the same velocity. This is synonymous to M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. The speed in the mass 1 is the same as the speed in mass 2. They share the same speed. V1 is equal to V2. Provided the bullet has entered the body, the masses will increase. They will now go at the same speed. The speed of the bullet will be lowered, while the speed of the body will increase. They will go somewhere at the middle, causing motion, and that motion will go at a uniform speed. Therefore, they are equal. We'll now take it away and now put just V to indicate they are equal. Then factorize. What is common here is V. Bring it out. Then you put M1 plus M2 in the brackets. This is what we call the law of conservation of momentum. Momentum is conserved. When a body with a greater momentum collides with a body with a smaller momentum, then momentum is what? Conserved. The one with a smaller momentum will increase its momentum, while the one with a greater momentum will do what? Lower its momentum. Conservation of momentum. A greater momentum colliding with a smaller one, when they collide, the greater one is lowered, while the lowered one is what? Increased. That's what you can see on the board. And this analogy explains better the equation. This is the first equation in momentum. Okay. The second key equation in momentum. The second key equation in momentum is this. Very key. Anytime you are giving question in external exam that involves first time change in momentum, and the body collide and go in the same direction, please use this formula. Then the third one is this. We'll take the second and the third at the same time. The third one is this. Okay, observe the formulas. You notice we have just one minus here. Here we have two minus. This is when two bodies collide and go in the same direction. When two bodies collide and go in the same direction, when bullets hits another body and they join and go in the same direction, or they don't join, but they collide and move in the same direction, please use the first formula. Ft is equal to mv minus mu. But if bullet hits the wall and bounces back, please use this formula. The second minus indicates that it changed direction. Bullet hits the wall and the wall bounces the bullets back. We use this formula. Ft equal to mv minus again to indicate bouncing back in opposite direction than before the initial momentum, mu. Therefore, this one can also be put this way. Ft is equal to mv minus times minus plus mu. This is opposite direction. Opposite direction. Opposite direction. Please take notes. In the same direction, the change in momentum is use minus. In opposite direction, you have two minus. One of the minus indicates opposite direction. Minus times minus plus. In summary, there is no motion in the absence of momentum. In summary, momentum is directly proportional to speed, provided the mass is what? Constant. The unit of momentum is the same as the unit of impulse. Therefore, momentum is either measured in Newton seconds or kilogram meter per second. Thank you. Stay tuned. Please do subscribe.